Good morning to all. Myself, Mr. T.M. Divakar, working as Assistant Professor in NDC Department in Sharad Institute of Technology, College of Engineering. So this semester we are going to study the network analysis. So before going to start our syllabus, let we know the examination scheme and marking scheme related to network analysis. So for this network analysis, we have 100 marks of theory and 100 marks of practical. In 100 marks of theory, there are 40 marks for the internal assessment and 60 marks for external examinations. In internal 40 marks, there are again 3 parts. Continuous assessment 1, it is for 10 marks. Continuous assessment 2, it is 10 marks, and midterm examination, it is for 20 marks. And for practical, there are 2 parts. 60 marks for continuous assessment and 40 marks for practical oral examinations. So this is about the marking scheme. In network analysis, there are 6 chapters. In first section, we are going to study 3 chapters, and there are 6 assignments, and in the second sections there are again 3 chapters, and also there are 6 assignments. These assignments will be considered for continuous assessment 1 and continuous assessment 2. So today we are going to start the basic circuit elements. So this is the overview of today's lectures. So we are going to see what is voltage, what is current, what is energy, what is power, what are the network elements, what are the parameters of the electrical circuit. As you already studied in twelfth standard or in diploma, let us revise all these parameters. First parameter is voltage. The potential difference in electrical terminology is known as a voltage, and it is denoted by phi. It is expressed in terms of energy per unit charge. It is expressed mathematically as phi is equals to W upon Q, whereas W is the energy and is expressed in joules, Q is charge and it is expressed in coulombs, and V is the voltage and it is expressed in a volt. As we know that in every atom there are positive and negative charges, and there exists a force of attractions. So the energy required to overcome this force of attraction and move the charge through the specific distance is called as a potential energy. Our next parameter is current. It is defined as the rate of flow of electrons in a semiconductive material. So this is the rate of flow of electrons, as here I am showing that. It is expressed mathematically as I is equals to Q upon T, whereas I is current, Q is a charge of electrons, and T is the time. The unit ampere is used to measure the current, and it is denoted by A. So 1 ampere is equals to 1 coulomb per seconds. This is the analogy of the flow of electrons, flow of current. The next parameter is energy. Energy is the capacity of doing work. Next parameter is power. So power is the rate of change of energy, and it is denoted by P. It is expressed in terms of watts. In mathematically, it is expressed as P is equals to W upon T, whereas W is the energy, T is the time, and P is the power. In the next, we are going to see the network elements. So we can classify the network elements into 4 types. Number 1, active or passive elements. Second one is the bilateral or unilateral elements. Third one is the linear or non-linear elements. Fourth one is the lumped and distributed elements. So let us see one by one. Passive and active elements. The active elements have the capability to deliver the average power greater than 0 for infinite period of time to the connected devices. For example, ideal power source, batteries are the example of the active elements. The transistor, op-amps, signal generator are also the example of the active elements. The active elements means to produce the gain, to produce the energy. The energy sources may be the voltage or current. Next one is the passive elements. Passive elements, it consumes or dissipate the energy stored in the circuits. The resistors, capacitors, inductors are the examples of the passive element. The next type is bilateral and unilateral elements. The bilateral elements are the elements whose behavior is same irrespective of the direction of the current. For example, any conducting wires and resistors are the best example of the bilateral elements. So once again, what is the bilateral networks? Whose behavior is same irrespective of the direction of the current. In other words, here I am giving the bilateral elements have the same Vi relationship for current flow in either directions. VI means the voltage and current relationship between the circuit. The next one is the unilateral elements. Unilateral elements are the elements whose behavior depends on the direction of the current. It depends upon the direction of the currents. For example, vacuum tubes, vacuum diodes, silicon diodes, rectifiers are the example of unilateral elements. This is the unilateral element. This is the symbol of diode. Here I am giving the power supply to the diode. So current is flowing in unidirectional. This is the transmission lines. This is the bilateral elements. Next one is the linear and non-linear. The linear elements have a linear VI relationship which is passing through the origin. Means the elements like resistor, capacitor and inductors are always constant irrespective of the change in time, change in voltage or change in temperature. These are the linear elements. So linear elements are always constant irrespective of the change in time, voltage and temperature. Examples are resistors. Next one is a non-linear element. So these are the elements change their values with change in temperature, change in time and change in voltage. So these are the non-linear elements. For example, SCR and tracks are the non-linear elements. Once again, non-linear elements are the elements whose change their values with change in temperature or change in time or change in voltage. The next one is lumped and distributed elements. Small in size and simultaneous actions takes place for any given cause at same time of instance are called as lumped elements. Lumped elements are very small in size. In other words, lumped elements are physically separable. These are physically separables. The next one is distributed elements. The distributed elements are not electrically separable for any analytical purpose. So best example is a transmission line. So transmission line where resistors, capacitor and inductance of the transmission lines are distributed along its length and they cannot be shown as separate elements. So these are the distributed elements. The next one is basic parameters. So these are three major parameters used in the electrical circuits. Number one is a resistor, second one is a inductor, third one is a capacitor. So these are the passive elements. We'll see one by one. Resistance. Resistance is the property of the resistor. It is the property of the resistor. So it is an electronic component which provides the specified amount of opposition to the flow of current. So resistors have a fixed value or they can be a variable values, and the value of resistor is a resistance. The unit of resistance is ohm. This is the ohm. The next parameter is inductor. Inductor is a coil or electromagnetic device that oppose any change in current. So this is the coil and that oppose any change in current. In other words, inductance store the energy in a magnetic field. And the value of inductor is called as a inductance. This is the inductance. Inductance is measured in Henry or millihenry or microhenry, and it is denoted by capital L. The letter L is used to denote the inductance, that is linkage of magnetic flux, and its unit is Henry. So Henry is a large unit, therefore millihenry or microhenry are the small units and they are used for the inductors. So 1 millihenry is equals to 1 into 10 raised to minus 3 Henry, and 1 microhenry is equals to 1 into 10 raised to minus 6 Henry. Next one is a capacitor. This component is having the ability of storing the electrical energy, and this ability of storing the charge is known as a capacitance. The unit of capacitance is Faraday. It is expressed mathematically as C is equals to Q upon V. The unit of capacitance are microfarad, nanofarad, picofarad, like this. So 1 microfarad is equals to 1 into 10 raised to minus 6 farad. 1 nanofarad is equals to 1 into 10 raised to minus 9 farad. 1 picofarad is equals to 1 into 10 raised to minus 12 farad. So these are the basic parameters as we study. Thank you.